Hi everyone, mathematical induction. In this video, we will see the introduction of mathematical induction, definition, applications, and principle of mathematical induction. And we will also solve some questions from the previous year question paper also. Okay, first introduction. The mathematical induction is one of the more recently developed technique of proof in the history of mathematics. It is one of the more recently developed technique. You can call it as technique, tool, otherwise method, which is recently developed in a history of mathematics. The mathematical induction is a powerful fundamental technique of proving the results about all natural number. We have to prove the results statements for all natural numbers only. Natural numbers means it's a counting numbers like 1, 2, 3, which is positive integer only. Okay. Definition of mathematical induction means the mathematical induction is a technique or tool, otherwise method, to prove the mathematical statement, formulas, theorem, which is thought to be true. We have to consider to be a true only, then only we have to use this technique to prove that theorem, otherwise formula, for each and every natural number. Natural numbers means it should be a greater than or equals to 1. Okay, by generalizing this is in the form of principle which we would use to prove any mathematical statement is a principle of mathematical induction. Okay, it is used generalizing. This is in the form of principle which we would use to prove any mathematical statement is a principle of mathematical induction. Okay, that means the mathematical induction means you have to understand that it is a one of the technique, otherwise tool. Otherwise we will use the tool na calculator, we will calculate the numbers. Like we have to, this is the one of the mathematical tool. You can call it as it is a mathematical tool, otherwise technique, otherwise the method used to prove the statements, formulas, otherwise theorems. Okay, for what? For all natural numbers, only natural number. Remember that is, this is the very important. You have to for all natural numbers only. For all the natural numbers. And applications means where we use means proving formulas like sum of the series. The sum of first n natural numbers. It is a formula is here n into n plus 1 divided by 2. Okay, using the mathematical induction we can prove this one. And inequalities, 2 to the power of n greater than n square for n is greater than or equals to 5. And divisibility problem like prove 7n minus 1 is divisible by 6 for n is greater than or equals to 1. And properties in geometry also so many properties will come. That is also we will prove by using the mathematical induction only. And in graph theory also, like proof of properties like Euler's formula for planar graphs, that is also we can use, we will solve using the mathematical inductions only. And algorithms and recurrence relations, this is also we will prove using the mathematical inductions only, like verifying the correctness of recursive algorithms and solving the recurrence relations in a computer science. All these we will prove using the mathematical induction, and in many others also. Okay. Now we will see the principle of mathematical induction. Principle of mathematical induction we already saw here. It is a generalizing. This is in the form of principle which we would use to prove any mathematical statement. It is called as a principle of mathematical induction. We will see the steps here. Okay, we will see the steps. To prove a statement P of n is true for all integers n is greater than or equals to a. A is here an initial number. A is here initial number. N is always we have to use the natural numbers only. N is greater than or equals to 1 only. Step here we have the 3 steps here. And conclusion. The step 1 is here base case. In the it is called as a base case. What we will do here means we have to prove this for the initial value. Means if it is the your series, suppose your series is start with the 1 2 3 4 n, means we have to prove P of n is 2. We have to take here P of n 1 is 2. Now see here, if it is suppose your series is natural numbers, sum of first natural numbers 1 2 3 n, what is that formula? N into n plus 1 divided by 2. Here what is the initial number here? N. So we have to prove, in the first step we have to prove P of 1 is 2. Okay, what is the initial value? This is base case. Prove that the statement P of A is true for the initial value A. Initial value is A. This step serves as the foundation of the proof. You have to call it as it is the foundation of the proof. This is the first step of the proof. But you have to prove for the initial value. Okay. Next step is it is the only assumption for the next step. Here that is called as the inductive hypothesis. That's the reason it is called as the inductive hypothesis. Assume P of k is true for some arbitrary integer k. You have to take any one integer randomly. That is you have to consider it as the k is any integer, any positive integer. Okay. It's a true. The statement is true for P of k. P of k is true. We are not proving here, just we are here assuming. In the step 2 we are just assuming here, step 2, and it is the step 1. Okay, this is the temporary assumption. It is a temporary assumption to build the next step. To solve the next step, it is a important. That's the reason we have to write the second step. Okay, that third step here, inductive step. First we will see what is the meaning of inductive. Step 3 here, it is called as the inductive step. We will call as the inductive step. Inductive means we will call it as specific to general. You have to go specific to general. Specific to general means, for example, you are observing so many examples, and we will conclusion the formula. Inductive and deductive, it will come to the deductive means it is reverse. It is general to specific, means we have to using formula to solve the example. That is called deductive. We are using here inductive means specific to general, means example to formula. For example, giving the examples means if it is a sum of even numbers like 2 plus 2 is 4, 2 plus 4 it is the 6, and 10 plus 6 it is the 16. These are the examples. Okay, these are the examples. For you observing these examples, we are making the conclusion that the sum of any two even numbers is always even. The sum of any two even numbers is always even only. So it is a conclusion. We will come to our conclusion. It will become now, it's a statement. Become as a statement. What is the statement? The sum of two even numbers is always even. Okay, it came as what is that? Conclusion. It will use the, just by observing the examples, we make one statement. We came to one conclusion. It is become as a statement. Okay, the inductive means it is from specific to general. From that meaning is examples to, we will consider the formula. Okay, that is only the third step. What we will do in the third step means using the inductive hypothesis P of k. Already we wrote in the second step, that is the assumption P of k is 2. That is, using that hypothesis we prove that P of k plus 1 is 2. In this step we will prove here P of k plus 1 is 2. This shows that the statement is true for n equals to k. What is this shows means? It is shows for n equals to k, then it must also be true for n equals to k plus 1. We will prove here n equals to k plus 1 is also true. Conclusion, if both the base case means first step and the third step, inductive step means third step, are proven after proving this two, P of n is true for all n is greater than or equals to a. After that we can conclude that P of n is true for all n is greater than or equals to a. A is what here? A is the initial value of our statement, otherwise formula. Okay, these are the steps for the proving the formula statements by using the mathematical induction. Base step, inductive hypothesis, and inductive step. In the first step and the third step we need to prove, and the second step just assumption. Just we have to write here P of k is true. Instead of taking n, we have to write here k. That's it. you have to write here P of k is true only. Okay, now we will see the questions so that it will clear more. Okay, we will see from the previous year question paper. It is a BCA first semester 2024 question paper. Okay, there is 3 sections. Already I told in the previous video so many times. Section A for 2 marks, section B for 5 marks, and section C for 8 marks. Okay, in 8 marks they asked here the mathematical induction. It's asked for 8 marks. Using the mathematical induction, prove that 1 square, 2 square, 3 square, n square equals to n into n plus 1, 2n plus 1 divided by 6. This is we need to prove using the mathematical induction. Okay, we will solve this one. It's a previous year question paper of Bangalore University BCA first semester discrete structures 2024 mathematical induction 8 marks 2024. Okay, using the mathematical induction we need to prove this series. Okay, some of the series, otherwise formula. Solution. What is the first step here? The first step is it is a base step. Base step means we have to prove initial value. What is the initial value is here? It's a 1. Okay, step 1, P of n for n equals to 1. What is the initial value here? A1 is here initial value for n equals to 1. We will take LHS for LHS and RHS. Okay, LHS here, LHS, it is a, we have to take n equals to 1. 1 means in the left hand side we have to consider only one term because n equals to, we are taking 1. So P of 1 equals to 1 square only. 1 square means it is a 1. LHS. Now we will prove for RHS. P of 1. Okay. Okay. P of 1. In the RHS, we need to substitute here. What is the RHS? First I will write n into n plus 1, 2n plus 1 divided by 6. This is the RHS. Okay. N equals to what we take here? 1. 1, 1 plus 1, 2 into 1 plus 1 divided by 6. It's a 1 into 1 plus 1. It's a multiplication only. 1 plus 1 means it is a 2. 2 into 1 is 2. 2 plus 1 is 3 divided by 6. 1 into 2, 2 into 3. It's a 6. 6 by 6 is 1. Just check here. LHS also came 1. RHS also 1. So LHS equals to RHS. Therefore, P of 1 is 2. P of 1 is 2. In the first step, what we do means we have to prove for n equals to 1. We need to prove for n equals to 1. So, after proving, it's a P of 1 is 2. We have to write the conclusion. Okay. Step 2 means it is a just assumption. It is called as the inductive hypothesis. The second step is inductive hypothesis. In this step here, just we are assuming the statement is true for n equals to k. Assume the statement P of n is true for n equals to k. K is any positive integer only. Okay, 1 square. Just what we will do means in our main question na series na, instead of n we have to write k. That's it. 1 square, 2 square, 3 square. Just see here, it's a n square is there. N equals to, we have to write here k square. In the RHS also same. K plus 1, 2k plus 1 divided by 6. Okay. Just what we did here, just we have to write in the formula n equals to k. That's it. We are interchanged n by k. That's it. We will give, this is the equation 1. Okay. Using this one only, second step only, we will build the third step. That's the reason we will use this one. That's the reason I gave you equation 1. Otherwise you can write by the second step. You can write it directly. Okay. Step 3. What is the step 3? The step 3 is inductive step. We can call it as inductive step. What we will do here means, we will prove here p of k plus 1 is 2 using the p of k, using the first equation. Okay. By using p of k statement. P of k statement means equation 1 only. That is equation 1. That is 1. Okay. For your understand purpose, that is 1. Now we shall prove that p of k plus 1 is also true. Is also true. Okay. How to prove this means, it's a, we need to prove here p of k plus 1 is true. Na, the last integer should, last term should come here, k plus 1 whole square in the left side. So right side also it will changes, k changes to k plus 1, k changes to k plus 1. So how to solve means, adding k plus 1 whole square on both the sides, because we first will make the, we will, by seeing the left side only, we will add on the right side. So it is 1 square, k plus 1 whole square, k plus 1 is true means, is we need to make k plus 1 is true means, the next step should come here, k plus 1. It will come here, k plus 1 whole square. Okay, in the left side. That's the reason we will add here by adding k plus 1 whole square on both sides of equation 1. Equation 1. Okay. So we will write here, what is the equation? 1 square plus 2 square plus 3 square plus k square. And what is right side here? K into k plus 1, 2k plus 1 divided by 6. This is the equation 1. What we are adding in both the sides here? K plus 1 whole square. Here also k plus 1 whole square. Now just see here. Now LHS says we got correct only. 1 square plus 2 square, 3 square, k plus 1 square. Now we have to solve for the right side only. Okay, left side I will write dot like this only. Okay. Now see here, just observe the right side. It is a k plus 1, it is a k plus 1 whole square. Two terms is there. So we will take k plus 1 common. What is left here? K, 2k plus 1 divided by 6. In the second term, k plus 1, because 1k plus 1 we took the common. K plus 1. Now we will take the LCM here. 6 is the LCM. K, 2k plus 1 plus 6k plus 1. Okay. K plus 1. Now we will open the brackets. K into 2k. K into 2k means it's a 2k square. K into 1. It's a k. 6 into k. It's a 6k. 6 into 1. It's a 6. Divided by 6. Divided by 6. Okay. It's the left side is as it is. The same thing only. The dots here. Next, k plus 1 here. Now add this one, 2k square, k plus 6k, it's a 7k. 7k plus 6 divided by 6. 6 we will take outside the bracket. K plus 1 divided by 6. Now see here, it's a 2k square plus 7k plus 6. It is a quadratic equation. We will split it 7k. How to split it means we have to take this k square coefficient and constant. We have to multiply that one. 2 6 is 12. Multiplication should come 12 and addition should come 7. So 4 3 is 12 and the addition of this one it is a 7 only. So you have to split it 7k as a 4k plus 3k. 2k square, 4k plus 3k plus 6. This is the rule for the finding the roots for the quadratic equations. Okay. K plus 1 divided by 6. I will put the bracket. Okay. Now we will take here 2k as common. What will left here? 1k left because it is k square is there. I took 2k common means k will left here. Here the 2 will left because 2k I took common. Here in this 2 we will take 3 common. K plus 2 because 3 2s are 6 here. K plus 1 divided by 6. I will write k plus 2. Again we will take k plus 2 common and what is left here? 2k plus 3. Okay. Now we will write here k plus 1, k plus 2. I will write this 2k plus 3 in the form of 2k plus 1. Like 2k plus 1 plus 1. Okay. Now just check it this one. 2 into k is 2k. 2 plus 1, 2 into 1 is 2. 2 plus 1 is 3. So 2k plus 3 I split it as, I will write here 2k plus 3. I will split it as 2k 2 plus 1. This 3 I took as 2 plus 1. After that I took common 2. So it is came 2k in this 2 I took common plus 1 as it is. Plus 1 as it is. So 2k plus 1. Because we have to write according to the formula only. What is left side here? It is a 1 square plus 2 square, k square, k plus 1 whole square. So divided by 6. Okay. So our formula, otherwise our statement is proof for, no, it's a proof for k plus 1 also, because left side also came it's same, k square, k plus 1 whole square. Right side also, instead of k it's a k plus 1, k plus 1 it's a k plus 2, and it is 2k plus 1, it is 2 of k plus 1 divided by 6. So this is proof for, now it is a proof, we proved here k plus 1 is also true. Thus p of k plus 1 is 2 whenever p of k is 2. It's very important to write the conclusion. Okay. Hence, from the principle of mathematical induction, P of n is true for all n is greater than or equals to 1. After solving the questions, compulsory you should write the conclusion. It's a very important. Hence from the principle of mathematical induction, P of n is true for all n is greater than or equals to 1. In the next video, we will solve other questions from the previous year question paper. Okay. Thank you. If you like the videos, means please press the like button and subscribe the channel and share the videos to your friends. Okay. Thank you so much. And don't forget to check the playlist.